Check the mic and make sure it sound right, boys.
Three, two, one. Hello, 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 and welcome back to The Arrow, our podcast. And today we have Mr. Apoorv. And I will tell you what we are going to talk about today, and that word is called data analysis. What is happening nowadays whenever I read newspapers, some technical papers, there is always this word data analysis, data science, data engineering. I don't know what it is because if you add a suffix or prefix to the word data, it is now becoming a stream for a career. And it was very confusing for me as a mechanical engineer. For us, data is just a report which we get after our experiments, and that is it. If it passes, it passes. If it fails, it fails. But when I was doing research about data analysis and all the streams related to it, I came to understand that actually data analysis is like astrology. We are doing predictions, then we are visualizing it somehow, and then we are giving a path to the businesses, like those astrologers give us the path to how to live for next 1 month, and we all watch our horoscopes every day in newspapers when we were kids, if we pass today in this exam or not. So I thought that let's discuss this and understand this from someone who is actually working in that stream, because honestly me and my co-hosts are all novices in this stream. And to better understand it, we asked Mr. Apoorv that please come to our podcast and explain to us what actually it is. And I would like Mr. Apoorv that please introduce yourself and tell us about yourself something.
Thank you, Varun, and everybody for having me in this podcast. Excited to talk about data. It's one of the key terms that are going around in this field. Brief about me. So I've been working in this field for close to 8 years, and I have worked with multiple companies or clients, like I would say, for India as well as outside, and have solved a majority of problems using data, majority of business problems using data, and help them achieve some of their business objectives, and have used majority of the mechanisms that are available in this field, that the field which is ever evolving. So yeah, so happy to talk about this in detail.
Great. We are also very happy to help you and very thankful to you for us giving your weekend, because I know how difficult it was for you to arrange a time for us. So first of all, I would like to start from very basics. As I said, we are all novices here. And my first question is, when uh, when I started thinking about or researching about what actually this data thing is, I came to read three terms which are quite similar to me, but still when I try to read about it, it is very different. So I want to understand from horse's mouth that what actually is the difference. And those three words are data science, data, data analytics, and data engineering. So
Got
I
it.
would like that you start from data science first, because I think science is the basic for everything. So yeah, go ahead.
Yeah. Yeah, that's right. And in the three terms that you have talked about, data science is the overarching terminology. Data science is a field of making use of data to draw insights, to draw knowledge, and then using knowledge to solve a problem. And within that, you would see data analytics, which is nothing but some of the mechanisms which are used to make sense of the data, right? What does the data says? What does it tell you? That whole umbrella of different algorithms or mechanisms is something that is called as data analytics. While data engineering is the the enabler of data science, or I would say data analytics, which is essentially the problem of how do you manage the data, how do you how do you ensure the data flows from where the data is getting generated all the way to systems that the organization own, so that there is no issues with the quality of data, there is no corruption. So that whole aspect or the whole world is called data engineering. In day-to-day applications, there is a lot of overlap in terms of data engineering and data analytics. That also depends on the problem that is being solved. So, but data science remains the top field, the word that should be used to describe this field.
So if I understand it correctly, science is the mother word for everything related to data. So data science is like the heading of the story, and then there is data analytics, which is done with the help of engineering. Am I correct?
That's correct. Yes. That's
okay.
correct.
But now I will ask a very silly question from you, which is also very basic. What actually is data? Because for me, a layman like me who is just a mechanical engineer, for me data is either numbers with different units, kg or centimeters, millimeters, or whatever. But what is data for you actually? Because when I think of data, that matrix screen come into my mind with all the green words dropping from the top, like if I am in some sort of movie. So what actually is data?
Yeah. So in true sense, data is just information. Anything that you are able to capture, store, and later make sense of, that is what is called as data. Data could be numbers, data could be words, data could be numbers converted from words. So you can create a data of, say, how, on an average, if you have 10 people and you ask each of them to write an essay, a data could be that how long does everybody's essay is. So then the data would be that person one, their data is n number of words long. So anything that you are able to store or can synthesize and store it in a certain way is just data. And then after that, any sort of business problem can be based on that data, which so that whole I would say the workflow of first storing the data, making sense out of it. Data again is any information. All of that comprises in this. So not just numbers, but a variety of other things.
Okay, if I remember my computer science classes in my 10th and 12th correctly, um, for a computer, everything is data. Our pictures are data, our words are data, our excels are data. Even if we write something in a story form, it becomes data in the form of zeros and ones. So for example, if I think about all the social media things, they also collect data. But how do they collect data? So I just know that a picture is a data. What else is a data which is new for us? That, oh, this is also a data for us?
Yeah. So the basic principle of everything is data from, what you, like you said, picture or word, everything is at the end, nothing but a series of zeros and ones. That principle has not changed. But where this whole game is being played is a little bit higher level, which comes where the data is now getting interpreted by humans more easily. Right. So in the field of data science, data, or what all data can be captured, is anything that you are able to make sense of. To give an example, if you have, let's say, banking industry, right? The basic data would be account ID, transaction value, transaction frequency, and the name of the account holder. That's the basic. But then nobody's just stopping you to start capturing what all you can store. So you can store what time does this client comes into the branch, which branch do they prefer to go to, right? Or it could be that how many accounts do they have. So anything that you're able to synthesize and store, you can capture, is at your disposal in this field.
I see. So right now, what I listen to, and when my seniors talk about, they always say that businesses now produce and store a huge amount of data, but unlocking that knowledge it holds, unlocking the knowledge it holds, the data holds, can be a very big challenge. And implementing a data analytics strategy is the key to finding out what your data can tell you and what uh, it can help you to take your business forward, right? So I would like to understand from you that what are the applications of all these three things which you told me: science, engineering, and analytics in businesses right now.
Right. So the way business problems exist today, they are very ambiguous, right? They are a lot driven by the core metrics of a business, let's say revenue or profit. But the way to achieve that is still very ambiguous. If you ask somebody who's running a shop, for an example, and he says, "Hey, I want to increase the profit," your gut can tell you a lot of things, right? You can say this guy should spend more on marketing. He should put a board in front, 10, maybe 10 meters away from his shop or near the main road. Another gut instinct can say maybe he doesn't have good diversity in the products that he's selling. Maybe he's only catering to a special class of products, right? So you can ask him to, hey, why don't you put more stuff that children like so that they will come more to your shop, right? Uh, so all of these are gut feeling. Now, when businesses are huge, in a small shop, the risks are very minimal, right? You can try something, you can fail, you can try something else in, maybe 2 weeks later. But in large businesses, the risk is very high. You will spend enormous amount of money on these gut feelings, and more often than not, one will hit, but the path to that will be very, very challenging. You will fail a lot if you just go by your gut. But there is where the data will help you, because you have been storing the data about your products, data about your customers, data about your own processes. You can use this data to test your gut before you actually take action. A good way to do that would be, let's say you're solving the same problem, you want to improve your profit, but here you have 5 or 6 hypotheses, right? Should I spend on marketing? Spending more on marketing will help me. Spending more on XYZ will help me. What you can do is you can use your data and say, uh, here was a region where I spent more on marketing. Was there a improvement in profit that I observed in the past? Here is another region where I had spent more on customer acquisition. Was there a uplift in the profit after that? And that way you can, in a mathematical terms, say that when I spend 10, every $1 spent on marketing gives me $3 in return, versus every $1 spent on customer acquisition gives me $10 in return. You will know exactly which path to take. You will still take the remaining paths, but the bang for the buck will be highest when it is backed by the data.
That is the problem with people who work internationally. You are talking about dollars, and I have to multiply it by 60, 70 right now.
Yeah.
Uh,
24
Yeah.
actually.
24 actually.
yeah. So, what is your specific position in this data industry? What actually you yourself do? So, accordingly, I will dive deeper into what to ask you and what to understand from you.
Yeah. So my role in this industry has evolved a lot. I'm a IT bachelor's degree holder from one of the colleges in Central India, and after that, I got into a startup which was specializing in data science field, and it was more of a consulting firm where businesses will come to the firm, but not necessarily it will be solved by data science, but if it is, it can be solved by data science, then that sort of solution will be provided. So that's where I kind of learned the basics. And at that time, I was working in specific problems, right? Where I have a business problem, I have the required data, and I was asked to give a suggestion. Or tell the business what is happening. Afterwards, as I evolved, as I learned more and more techniques, today my role is essentially to more of translate the business problems or layman's problems into a series of ML problems or data science problems that should be solved. And that way we get closer to the objective. The way you can think of my role is that the business problem can remain same. For example, we want to be better in terms of responding to our customers. A generic person or person who is not specializing in data science field will solve it through improving SOPs, right? As standard operating procedures that we will respond to everybody within 6 hours. if we miss their call, or if we do take their call, we'll try to give them a resolution. That's the generic way of solving the problem. Data science way of solving the same problem would be how do we have good enough manpower? How do we predict how many calls will come when? Right. So I specialize in basically converting programs or business problems and solving them by providing insights through data. You were speaking about strategy, organizational strategy using data. More and more, what is happening now is each and every organization is learning to understand that data science or usage of it can give them the edge, information that they otherwise won't have, and they are investing heavily on this aspect as well.
Okay.
Well,
Yeah. Okay. Abhimanyu,
uh,
go ahead.
yeah, yeah. Well, Apoorv, you have given very good insight about the what is a data actually, and it could be industry specific. Maybe it related to healthcare, education, or any manufacturing industry, or product related feedback from the clients. What kind of customer requirements? But I see the data available in a world, maybe it is in a web form or we are taking from some agencies. It will have a lot of junk data as well, right? Okay, so when you get the data, what are the stages you go through seeing the data or visualizing those data, and how do you use those data to solve the real world problem in exact? So what are the process behind those before you reach on the conclusion?
Got it. So it's a very good question in the sense that this essentially involves the entirety of what a data scientist or a data analyst does, right? Uh, in technical terms, the junk that you talked about more or less are interpreted using a terminology called outliers, right? What this means is that if the folks, everybody has ballparks, right? For example, you know that if you are running a call center, you get 10,000 calls a day. But if you have a data which says on 16th of May, 1 million calls came, your knowledge of your own business, the ballpark will tell you that it doesn't make sense. But when you have a lot of data, you may not have the ballparks known for each and every kind of data,
What is
or
this
you may not have.
ballpark? Can you tell us?
It's essentially an estimate that you know, because you have been working with that business. A guy who is running a call center knows that I get 10,000 to 12,000 calls. So when he sees a data which says on a 16th of May there are 1 million calls, he will say there is something wrong with this data. Maybe you've added more zeros, right? Or maybe our data capturing mechanism has gone wrong. So that's that's what somebody means when they say ballpark. But what I was coming to was that in this data science field, there are just so many data points that gets recorded. It's very hard for everyone, how so experienced that they are, to be able to know what their data should be. And therefore, there are scientific mechanisms which are used to remove this junk. Theoretically, it's a very vast space. In application, there are just sequence of steps that you need to perform when anytime that you get the data. So a data analyst will know, for example, if I get a data, I will check what is its average, and I will say, how far along are certain values from this average. If you know that, there are 3% or 2% values which are very, very far along, very likely I don't have to consider it, because with the amount of data you're dealing with, millions and millions of information, removing few outliers won't, impact. So that's the first process. The second process is data visualization. Somebody should know what kind of data they are dealing with. More often than not in this field, the person who is the data analyst is not a subject matter expert. The problem could be a banking industry, pharma, airline industry. They have not worked in that. So what they have to do is they have to ensure that they are at least on the same level as somebody as their business customer. Right?
Okay. You just use this word, data visualization, right? What I understand from data visualization is that you are using those zeros and ones to make certain picture out, so that a person like me who is running a business right here, can see it on paper or a presentation. So how is that data made usable actually? And how do you visualize that data to use it? And what are the
Right.
inputs required for that data? I mean, if I'm running this business right now, which is a multi-billion, I can say whatever I want because it's a fake business. So it's a multi-billion business I'm running right now. And I want, I will hire you as my data analyst and ask you, boss, I want another billion profit every second. I want to be richer than Jeff Bezos and Elon Musk. So what will you ask from me, and what will you give back to me?
Got it. So let's say you are looking for, in this case, the what you have explained, you are looking for recommendations, you're looking for direction, right? Most probably what has happened is that your business acumen or your knowledge of your own business has reached you to that $1 billion level, and now you have hit a roof.
It's 100 billion, more than
It's
Elon
100
Musk.
billion. Right. So let's say you have hit that roof, right? And now you're thinking, I have applied what all I know. I was the subject matter expert or the ninja in this field. I've applied what I know. Uh, and now you have to give me recommendations, and you have to just, let's say in this case, you have to improve your profits. What a data analyst will do essentially is first they will ask you what kind of data you have been storing all this while. And let's say you have given all of that to them, right? They may come up with few more asks. So they will say, Mr. Varun, you work in this field, but you don't have rich data about how your customers react to your product. Maybe you have not been running good enough surveys. So he may ask you to spend few $1 million to run surveys. He's just asking you to generate more data. Once he has enough data, and it's a very ambiguous situation. You are looking for recommendations. He will create an objective function. In this case, objective function is, what do I want to do, right? In business sense, I want to increase my profits. In for a data analyst, it would essentially be a number, right? He will transform your profits, which are mostly at a quarter level, and he will say Q1 to Q2 the profit increase was X, Q2 to Q3 the profit increase was Y.
Mhm.
He will then, what he will try to do is, he'll try to attribute this profit to the rest of the data that you have stored, right? He will create hypothesis. He will say, uh, uh, acquiring 10,000 more customers resulted in increase of this profit. For now, he will just create hypothesis. He will say, spending market money in marketing has helped in improving profits. So he will have a laundry list of some of these hypotheses, and that he will try to then prove or disprove this hypothesis,
Mhm.
right? He will say, when X dollars were invested in marketing, was there impact on profit? And the key aspect or the key value that a data analyst adds here is, he has the ability to look at things in isolation. He will clean the data, he will engineer the data in such a way that in the real world, a lot of things are happening. You're running a marketing campaign, you're also acquiring more customers, you're also doing a lot of other things. But he will try to engineer the data to just only attribute marketing to profit. And that way, finally, he will come to you with a recommendation, and he will say, uh, there is a lot of potential in doing X in this region, right? Uh, and we have that is untapped. So you should invest more. And you will ask why. How are you so sure that taking this as strategy will help me? He will say, hey, because in 2020 you had done the same in this region, and characteristically these two demographies or these two geographies look same. So if you had succeeded there, you will also succeed here. The thing is, he is still not sure. He's just telling you what your own data had in store. He's just making sense out of it and giving you direction, because you're yourself a subject matter expert, right? You will eventually be able to take a call. A business person will eventually be able to take a call whether a recommendation is something that makes sense or not. And that's the final call that a business owner has.
Yeah, but I still don't get, what will I get? Will I get an email presentation from you, or will you ask me for a meeting and just explain it to me in a big 70 TV? What will you do for me?
There are
And
different.
because to make myself more clear, because when I see visualize for me is in either in the form of pictures, presentation, or a movie, right? But when you are playing with so many of zeros and ones, what output and what kind of output will be there for? Because I am a layman, I have not studied more than 10th. I just found 10 oil wells somewhere in under my house, and now I am a multi-billionaire, right? So you have to explain it to me. What am I doing? Oh, sorry. What should I do? How will
Yeah.
you explain it to me? Because I am asking this question is that because obviously I am not that big. Obviously, I'm not so much rich. I'm not so much read or well. I'm not even intelligent in this matter. But I want to use you, right? So explain a little bit more about this visualization process.
Yeah. So in a the way I will like to introduce one term which is called dimension or category, right? That's how you can break a business or a business problem or an ambiguous problem into chunks that you can interpret, right? If yours is a oil business, then some of the dimensions would be throughput, right? How much you can produce every day. So throughput is a dimension. One of the other dimension could be post processing or refining. Maybe you don't own the refining, but there are companies. There are 5 companies that you have worked with in the past. So that's another dimension. Third dimension could be investments. Oil is a non-renewable resource. So maybe you have used the money in the past to invest in research programs. And there is a research program happening in Arabian Sea right now. So that's the third category. A businessman will break, whether intentionally or unintentionally, their own business in categories like this. A data analyst will come in most compressed form or most succinct form with recommendations. Do X in your this category, and you will have Y in your objective function or the final profit, right? It can be converted, but let's say you are not happy with that recommendation. You say, why do I trust you, right?
Mhm.
You are saying this, why do I trust you? And then that's where the visualization comes in, right? You think, imagine a bar graph where you have uh, results of investment in research, right?
Mhm.
So you will see a bar graph of ocean 1, bar graph of ocean 2, ocean 3, ocean 4. And there you will see, maybe in the graphs you will see for Arabian Sea, you will see square nautical miles researched or invested upon for scanning, and the return of it. You can think of it as a heat map also. I can convert the whole ocean into a heat map where green will mean no reserves, orange will mean some reserves, and red will mean more reserves.
Mhm.
And that's when you will be able to say, okay, if I have to, that's essentially what the data has told, this guy in the past. And he's saying that now you should research more in Arabian Sea in this region. The reason for that would be because you're looking at that in the heat map. You're seeing more reds there, or more more oranges there, where you think you should invest more. So this is about how you are comfortable with what level of trust you have with a data analyst, and the more you ask, the more he will be able to use more and more such visualizations to help you.
Apoorv, I am, as I said, and I will say it again a million times in future, that I am a mechanical engineer. And one thing what we do is called sort of structural analysis, thermal analysis, things like analysis with as a prefix or suffix. So what we get as an output, is like, if I have, for example, just a basic example, a cylinder, or take a water bottle like this. And when I do structural analysis of this thing, I will see that this part is green, it becomes yellow, and it here becomes red. And then when it becomes red here, people say, okay, here it will break. So give a rib like this here. This will make it stronger. Okay. Now, when you say that you give us recommendations, right? And those recommendations are probably in the form of bar graphs or maybe even a single line, right? And right now you were explaining that this is red, so do it this something like this. But all in all, when the visualization happens, there has to be something which should say that, okay, if you ask me to make this red green, I should invest ₹1,000,000, not dollars, ₹1,000,000 here. But if I do not have ₹1,000,000, I can only invest ₹500,000. Now, what will happen? Will you give me a sort of a calculator to do this analysis now myself, or should I have to go back to you again? Will you change the inputs again and your recommendations again? And is this is an all in all, is this an iterative process?
Yeah, it's a very good question, because what you're adding here is called a constraint, and a lot of times in real world problems this actually happens, right? You start with a very unconstrained approach, and by the time you reach to a recommendation, your recommendation may be like invest 1 crore rupees here, but the business owner will say, yeah, I'm not going to spend 1 crore on this pilot. I'm not going to spend 1 crore on this new thing, right? So you're adding constraints here. One of the key element here is probability. If you have data, you will be able to calculate probability. And if I have a 1 crore rupees, or let's say you have a thought of investing 50 lakh rupees only, I will try to do further iterations, right? There are a couple of ways. I can say probabilistically, if you have invested 1 rupee here, you get 80% returns most of the time, right? But that could be one of my recommendations. But I can also change my recommendation to diversify. I can say, doing this gives you 80% returns, but it has failed 3 out of 5 times in this particular month, or in this particular reason, whatever that is. So I'll add one more recommendation. All in all, I will give you as a recommendation how to properly invest your 50 lakh rupees. And the call that you will eventually have to take as a business owner is which recommendation you want to pursue. The one which has the maximum risk but maximum return, ones which is let's say a little bit calibrated. But a data analyst will help you understand what is the outcome with each of these 3 approaches. Maybe you had the 3 approaches to begin with, but now you will be able to say what is the outcome of each of these 3 approaches. Now that can just be a single line in email. It can be some flashy picture. It could be a flashy bar graph. But as long as you're taking the key recommendations out, I think a data analyst purpose gets solved.
So has it happened to you in your experience that some customer of yours, right now I am that customer, I have oil wells so I come to you and ask you to come to my office and we discuss and change these things in front of me, and based on that your recommendations are not what you actually want to give, right? It's not the real thing which you want to give, but it is the constraint from that customer. At that time, how flexible is data analytics?
Yeah, it depends on the sophistication which was involved in giving the recommendation in the first place. With large amount of data, the processing also takes time, right? Sometimes people's algorithms itself take maybe 6 hours to 8 hours to generate a prediction or to generate a recommendation. And in those cases, probably you'll get a response that, thank you for your constraints, we'll come back in a week, right? With and there you also have to keep one more thing in mind. What is a good enough estimation? This is all estimation that we are talking about, right? Where accuracy is most important and where accuracy is not that important, a ballpark or a estimate, good enough estimate works for you. I'll actually talk about a real world example, right? Let's say you are building, you are estimating, or you're building a mechanism to detect fraud, right? You're a business owner, and there is a lot of insurance frauds, let's say, that are happening. So your recommendation would be, in this case, would be that, hey, anytime you get a claim, you pass through my problem, and my problem will give it a score from 0 to 100. If it is 0, it's not fraud. If it is 100, it is very likely to be fraud. That's the outcome. It's just a script, right? You will get it. So every claim will have a number associated with it, right? And now we are in a business meeting and you are telling me, Apoorv, tell me, should I trust this system? The question that I will ask is, I have two modes, of my solution. One is you will never let go of a fraud, which means every time a fraud happens, I will calibrate my system so that every fraud is detected. But for that, you have to employ 100 people to look at all my recommendations, because one person, let's say, is only able to employ one person. One person is only able to scan through one claim per day. Then you have to have 100 people. But maybe you have put a constraint. I can't hire 100 people. I have only 5, right? So then I will calibrate my recommendation in such a way that I will say, Varun, if you're giving me 5 people, the max I can calibrate my recommendation, I can come back in a week, I can calibrate my recommendation that 80% of the frauds I will cover, 20% I will not be able to cover with the constraint that you have put in, right? And a lot of this is what a data analyst really does, or a data scientist really does behind the pictures. They will have not one recommendation at any given point of time. They will have 3, 4, 5 recommendations, and based on the money that or bandwidth a person is ready to invest, they get different solutions.
Okay, so Apoorv, one more question about flexibility. As I said, by that I am a mechanical engineer, and the thing which we get in the form of analysis is most of the time it can be extrapolated. I can extrapolate this thing of 1 millimeter thickness, but of same design, and convert it into a big part which is a meter thick using extrapolation, or should I say even unitary method, which is taught in class 6 or 7th. So is this data analysis also this flexible, or the input has to change every time?
Got it. So there are 2 ways to look at it. One is that at the time of when you are building the solution or coming up with recommendation, you ensure that you will be able to do extrapolation. By that, what I mean is that if you have built a methodology using 100 rows or 10,000 rows, you first test it out whether it will be equally applicable in, let's say, 20,000 unseen rows or 20,000 unseen cases. And only when you have statistically ensured that that is happening, that your solution by design can be extrapolated, right? To give an example, let's say there is a solution that will tell me what kind of customers will buy my product if I send them an email, right? And this is a solution that I had first, let's say, deployed in India, or let's say one state, Maharashtra. It is very relevant that my customer will ask the same solution for the other states. And at the time of designing my solution, I will have to ensure that that level of scaling is possible, that level of extrapolation is possible. But let's say I've not done that, the second approach. Let's say there is something, and it happens mostly in countries when you're talking about, let's say, Middle East, something was working, now you have to apply in India, or in US, now you have to apply in India, like that. At that time, you have to start from scratch, because there will be a lot of intricacies or characteristics of each different dimension or different geography. Right. For example, in US, let's say there could be a characteristic which does not make any sense. Right. It's a fairly developed country, so a poverty line or there, let's say, minimum wage is a concept, right? But in India, such a concept doesn't exist. We have different ways of different, let's say, data points to calibrate, let's say, somebody's social well-being. So what an analyst has to do is he will keep the principle same, but the data that he had used, he has to transform that to something that makes sense for the newer geography or newer solution. So there is a little bit of iteration involved here in the second approach if you have not started with keeping that in mind in the beginning.
I see.
Okay. Well, Apoorv, regarding this algorithm, and like you have given one example of product demands in the any state or other state, or maybe in different countries. for example, I just divide that in a much lower level, uh, and you have taken the data for last 10 years, but the product demand in the last 10 years in the villages or in the cities will be different. But as we move ahead, maybe the now demand will be quite more in the villages. So the previous data might not give you the correct visualization. So how frequently you change your algorithm or model, because this is a quite a dynamic situation, means model which you are using today, after 10 years it might not be applicable, you have to improve something. And as you are telling, you have already talked about the flexibility, and there will be some certain number of assumptions. So how frequently you change, and if you are not changing, what are the factors you carry in your model which can be used in the future?
Right. So, in a general sense, if you are building a model is nothing but a algorithm or a mechanism that imitates real world, right?
Exactly.
If you're not changing it, it will become obsolete after a while. In certain business as applications, these sort of models are trained with newer data every week, sometimes
Oh,
every day also. And that depends on the problem, right? How much variance there is in the data that you have been capturing. For example, let's say you're discussing about customer demand and you're predicting customer demand in your model. uh, Money or inflation is a factor. So something that you have built today will not be, or maybe let's say 100 rupees today is, let's say a good enough amount of money for somebody to have for somebody to spend their day. But maybe 5 years down the line, that will not be the case.
mm,
And then you very simplistically put, you don't have to create a new algorithm. You just have to show it newer data, right?
okay.
So you just feed newer data in, you get better output, and that's just calibration. There is another aspect though, and when there are certain businesses or a business can say we can't afford to train it, or we can't afford to have wrong output even for a single day. Maybe you are saying we should train it every 6 months. I will say, what on the 5th month and the 30th day you will not be accurate, right? So maybe you don't want to afford that inaccuracy.
Okay, I would like
That's
to just interrupt. You are telling the training the model. So what actually the training the model? Is it you keep collecting the data day basis or maybe the weekly basis, and then you generate some output and you keep matching how consistent these outputs are, or is there something else?
Yeah. So the crux of the algorithm will remain the same. Let's say if customer driven demand is driven by the same person's, let's say, what are the number of orders in the past? How many customers do we have? Let's say number of orders, number of customers, and let's say the geography are three things. And you have built an algorithm where you say if geography is A, then demand will be 2 times of previous demand, and maybe something else. So this algorithm will remain the same. What will change is number of orders will change over 6 months, right? Or number of customers will change. So earlier your model was taking 10 as an input and giving 20 as the demand output. But now most likely it will work by taking 20 as an input, but 40 as an output also. But let's say a new thing has come up, right? Then you may have to feed in more data, or maybe you have to change the algorithm also a little bit,
Okay.
right? So that's what mostly what training means. And a key aspect of keeping things up to date or getting the best predictions is what we call as feature or signals, right? When you say things have changed, things are not same in 2021 as they were in 2000, you're saying that based on something, right? You are maybe saying that based on population. You are maybe saying that based on the rupee to dollar ratio. You are maybe saying that with respect to customers. Analyst can incorporate these signals as well in their algorithm. The more sophisticated, that's what I mean by sophistication. The more they incorporate the signal, the better accurate their final solution would be when it comes to, let's say, predictive modeling.
So overall, I understand is when you have more number of data points or data factor, for example, like Varun was talking about the running the business and getting the profit. So if I have 10 data points, then my result will be different. If I have a 20 data points, 20 data points of 20 different type of input data, so my result will be different, right?
Yes, and that will be the make or break in terms of accuracy, right? For example, just taking a detour, but it will be easy to understand it that way. Let's say you want to predict which team will win a match in, let's say, Bangalore's Chinnaswamy Stadium, right? Basic
CSK.
idea is, okay, yeah. So the basic idea is this: first signal that you have thought of is team. Which two teams, right? So your basic algorithm will be team, and then maybe you want to convert the team name into players statistics, right? So you will say, you will convert the data in terms of how many bowlers, how many batsmen, how many all-rounders. Within batsmen, you will say what was the average. So that becomes your data. So an algorithm can become like that whenever a team with 6 batsmen whose average is more than 40 in a T20 happens, the team like that will win. That becomes a prediction, but nobody is stopping you there, right? A signal you can add later, and let's say you use this model, you've been using this model for prediction, one day it goes wrong. And now you're sitting and thinking, why did my prediction go wrong? Why did I predict incorrectly? And the guy who is in the business, he will say, bro, it rained today. And you will realize, I did not incorporate rain as a signal. So next time you will redo this model and you will have rain as an input, right? Maybe you are going right all this while, and suddenly one day again you will go wrong, right? And this time you will ask the business owner, why did I go wrong? Or you yourself will ask, why did my prediction go wrong? And you'll say, this was an away match. This was not a home match. And now the question comes to you. This is a very subjective concept. Away games and home games. It's very subjective. How do you convert it into data, right? I can say, if you have money, I can ask you to give me the data of the population of the audience. I will say, I will convert it into number in such a way that 60% of my population is home and 40% is away team. So whenever the audience population is higher than 60% for the team for which you are predicting, the team will win, otherwise they will lose. So now you have converted a subjective term into an objective or a number. And that's the way you can keep on making this algorithm very complex. Sometime later, you will say this model has been working fine. And a year later, or maybe 10 years later, you'll say now this model is not. And you will realize why? Because they've changed the quality of the ball, right? The ball that is being used is not right. Then you will realize, okay, maybe training will help here, but this time I'll only keep the pink ball matches in my training data, remove the white ball matches in my training data. That is what we mean by training.
So Apoorv, my next question will be, again, I found oil wells. Now I found coal mines also. And accordingly, I will ask the questions that I have gone through the literature of data analysis, and there were two words popping out many times. And for me, I think they are quite important. One of that is data pipeline, and another is called data mining. What are these two things, and where does it come into the picture of data analysis or data science, for that matter?
Yeah. So to kind of remove the confusion with the way things are evolving, these words are kind of interpreted incorrectly. But whatever I have explained in terms of data science, data mining is nothing but very similar to it. Data mining is nothing but using the data and making sense out of it. Again, like I said, it comes under the umbrella term, right? So you can say data mining or data science in today's world is kind of synonymous, or the application of data science can be interpreted as data mining. What is data pipeline, right? Data pipeline is everything from an infrastructure perspective that needs to be done for you to even start running experiments or making sense out of it. In very layman terms, let's say it's just a workflow, right? You are an analyst, you want data to start your work, but you want data. So there is a workflow which says that every morning 6 a.m. you will get an Excel file which has the details of all the cricket matches that were played last week, right? But you're not happy with this. You're saying, I don't want to wait a week, right? So you will ask for better frequency. So you will say now you will get a mail every day. So the whole flow of from data, where the data is getting generated, to the platform where the data analysis will eventually takes place, is something called as data pipeline. In real world, it's nothing but there are so many sensors everywhere now, right? If you're using a vending machine knows how many items are remaining in the vending machine, or where the vending machine is located, what's the temperature of the vending machine. So all of this data is getting generated in seconds, and you have to ensure all of this data flows back to the company's systems. They are stored, they are queried in the sense, if I ask something, if I want to get some data, I'm able to get the data out. The workflow of that involves a lot of engineering in very, very technical terms. And setting up that is what you would understand as data pipeline.
Uh, so what I understand correctly is that data pipeline starts from the scratch and ends at the output. Whatever happens in between it is actually the pipeline. So the process is called pipeline.
The process would be called engineering. The outcome will be called as pipeline.
Okay. And because I was so intrigued by this word data mining, because for me mining is like a treasure hunt where you go with a beeper,
It is. Yeah.
find and then go deep inside earth. So where do
Yeah.
you dive? I mean, what do you mean? You said that it is as similar as data science, but still, do you dive somewhere, or it is just a term, a fancy term coined up by some engineer or a scientist?
Right. See, if you have a problem objective in mind,
Mhm.
right? The core mechanism that a lot of people just operate is have their gut feeling or their hunch in form of hypothesis. X happens, therefore Y happens is a hypothesis. X leads to Y is a hypothesis. And then you simply use the data to see whether it's actually true or not, right?
Mhm.
That is when you have a business objective. So their mining is driven purely by the hypothesis that you have, but that's not always the case. Maybe sometimes, uh, let's say you're monitoring Twitter, right? And you run a company, and you want to know what are people talking about your company, what are the key topics. So you don't have any hypothesis, you don't know anything. That's where mining concept comes in, right? So what you will do is you will first use the API or the programmatical mechanism which Twitter exposes, and you will say, give me all the tweets that have my company name, right? And then what you will do is you will want to understand, are they talking positively about your company or negatively? A data analyst will basically build a system which will synthesize the I would say the messaging or the meaning of a tweet. So they will say, if there are words like bad, worse, poor, right? They are talking in maybe negative connotation. If there are words like faster, improved, best, then they are talking in positive connotation. Mining essentially will basically convert these tweets, which you can't read because there are just so many, into maybe 2 bar graphs, which will say if there are 100 tweets, 80% are talking in positive light, 20% are talking in negative light. And of course, you now know you are running that business where you will dive deep. You will dive deep in the 20% which are talking negative. Why are they talking negative? Which kind of customers are these? Which geography do they belong? What words are they using? And then data pipeline will come in, right? You will say, maybe your customer department will come in there, please share your order ID, we will dive deep, right, in that bad tweet. And then your data pipeline will help you understand which order were they talking about when they tweeted, of the 100 orders that they had placed in your company. And then you will be able to marry these two, and you will say, whenever we ship items like this, for example, a very, very genuine insight can come where say, whenever we ship glass items, people don't like our products because they break in transit. How did you arrive at this conclusion? Because you first understood tweets with bad connotation, married with the order data, and you were able to come up with such a insight.
I have one more question. What you gave this example, I want to ask that. For example, not for example, it is a reality actually that right now the markets are too dynamic. I mean, everything changes in seconds sometimes. I mean, people are losing the double the earned money from Dogecoin now in overnight or in seconds. So when I asked you earlier that how dynamic it is or how fast it is or flexible it is, so it has a processing time, or should I say the pipeline has some kilometers of length, that the output and input and output has some time between that. Now when this market is so dynamic and I want to be I want the input and output like what we see in the stock markets with a graph which is running live, and I can be also dynamic, always on my foot, and I can make the people who have hired in my oil and coal industry now to work overnight and clear that thing. So is that a possibility in data analysis, or it will always take this much of time, or does AI comes in the picture at this moment?
It's a good question, because anybody who is able to make this as dynamic as possible will win the game. Data analysis is very democratized today, and any company or any organization which is able to make it as real time as possible will win the overall game. You were saying this, and a recent example came to my mind. When pandemic started, all of the airline companies' algorithms, which decide the prices, right? They are driven by a key concept, which is that if there is no demand, lower the price, the demand will come and it will plateau, and then it will increase again. And this was the core crux of each and every algorithm which was deciding airline ticket prices. In pandemic, though, these algorithms were not checked, right? And what happened was, with because of lockdowns, the demand went down and down, and you will see the airline prices never, the way the algorithm was written, they never understood that this is a macroeconomic factor, and because of that, the the ticket prices went low and low and low and low, right? And you would see ticket prices for being $5 or $6. That is a situation where an analyst or a scientist, when they were building, did not incorporate that as a feature. So they were looking, they missed a factor of when the demand was not met, the algorithm has to behave differently. So I'll go back to the answer to your question is same as before. It all depends on the factors that you have thought of in advance for any prediction to work properly. If you have not thought of it, maybe you can then use an mechanism which will help you discover those factors. But whether you want to use it or not, it still remains something that an engineer has to solve.
Okay, before we move on to Naveen, I have a few more things to ask from you, because obviously we cannot discuss everything in 1.5 hour podcast and give all the information. People have to read themselves, research themselves. But I want to understand the definitions of again some words, and those two words again they pop up always, and they are called machine learning and big data. So whenever I have one page of theory about network data analysis, this machine learning is in the first paragraph and big data is somewhere at the end of it. What are these two things?
Right. So there are two branches of data. I would say at a high level, there are two ways. I wouldn't say theoretically there are two branches, but there are two ways you can understand it, right? One kind of problems are descriptive. Tell me what happened. Use my data, tell me what happened, right? Another type of problems are inquisitive, right? Why is this happening? why is this? Why did something go down or something went up? Then the third kind of problem is prescriptive. Tell me what I need to do, right? Tell me what should be done. And the last kind of problem is kinds of problems are predictive, right? Uh, tell me how I can plan my future. Tell me how this will behave in future. So that's the fourth kind of problem. Machine learning as a term majorly deals with this prediction.
Okay.
Okay, because you're not talking about present or even past. Now you're talking about future. And machine learning are a collection of algorithms which are able to understand the relationships between the data points, the factors that we were talking about, between rain and between cricket team, between balls played, between all of this. And once that relationship is established, able to have a say on future, right? What big data is nothing but application of these algorithms into large and large amounts of data. Big data is nothing but it's talking about scale. When we had at max, maybe Excel had some 100,000 rows. Nobody used to fill them in the past. Right now we are not even talking in terms of Excel. We are talking in terms of data which people know is getting stored, but they have not looked at the full length and breadth of it. They are just trillions and trillions of records. And I was speaking earlier about the difference between first building solutions using sample and now building solutions using the entire data. The algorithms with the compute power that we have today is able to understand relationships of all of these data points that you have, which will be as similar to the real world as possible, and then use that data or that algorithm, essentially the relationships, to say about future. So if you give this algorithm, let's say number of balls played, rain probability, number of bowlers and all of this, and the objective function was now onwards will the team win or not, something that you will see nowadays when cricket matches are actually being played, the probability of a team winning in real time. As and when you are giving the current state to this machine learning algorithm, it is giving you the prediction of what is likely to happen.
I see.
Apoorv, many engineers are also seeing us and listening all the data related things we are talking. So my question is very basic, and which is we talked about different mechanism, different analytics you are doing. So what are the different platforms which are already available with the companies in the market? And my second question is, again, when I'm saying that many of the young engineers, or maybe those who are pursuing their engineering degree, they are seeing us. So how your college degree help you with data analysis in any way?
Got it. So there are three key aspects, right? One is answering your first question. One is data access, right? Accessing the data, querying the data. That's the first thing. Second one is data manipulation, right? Making sense out of the data. And third is data visualization. From a platform perspective, there are solutions that exist today which deals with each of these three differently, like alone or sometimes together as well. For example, from a data storage perspective or data accessing perspective, there was things like Oracle RDA-PMS. There was stuff like Microsoft Azure, Amazon AWS. Those are your mechanisms to store the data. Data manipulation or data storage is nothing but how you can interact with this data. If you want to know the top most performer in a cricket match, you will try to say, give me topmost performer in this cricket match through a code, right? So there are certain coding languages like SQL and so on and so forth. And then there are certain UIs, drag and drop also, where you can just say I need cricketer, and then you'll select greater than sign, and it will give you the maximum best performer. So there are solutions like this. The third one essentially is the data visualization. There are solutions like Tableau, QuickSight, which essentially converts the data which is in numbers and a lot, lots and lots of rows. It converts into dimensions. So maybe it will give you, by dimension, what is the, what's the maximum production from a production line, which geography is doing that, or number of workers by particular business unit. So there are different solutions which are there, catering each of these three aspects. From a how does your business degree help in? Data science is a field which is now is open to everybody, and majorly there is one key differentiator: the theoretical knowledge and the application. When we talk about theoretical knowledge, there is a separate path that a lot of people take, which is after they do their engineering, they choose to pursue their master's or PhD in data science. And we were talking about algorithms, right? They are the folks who are investing in building better and better algorithms. These are the guys who are picking up the intellectual property that was created in 1960s and ensuring that it is applicable and evolved in today's world. That's the theoretical arm. And then there is an aspect of application. Here, it doesn't matter which field you had taken in your engineering. It doesn't even matter whether you're an engineer or not. You have to apply. You need to know what tools are available at your disposal and how you can use that tool effectively. And there, anybody who has the curiosity, who likes to deal with large amounts of data, who is able to interpret or who is able to think differently, think the different hypotheses that might exist, is able to come up with what are the desired recommendations, is able to interact with the business people properly. They will be here who will be able to correctly apply the theoretical knowledge using the three tools that I was talking about earlier.
I see. Go ahead, Naveen.
So, like a common man, when you are telling that, even an engineering degree is not at all compulsory for any person to go into this particular field. So the thing is, what are the different certification available to pursue or to make future in this field?
Right.
I would add something to these questions, because including certificates, what are the, that word called nanotechnical skills? What other skills also we require? Personally, we have to develop in ourselves, because there are, as Naveen said, that there are many budding engineers who want to know what can they do, because obviously this seems like a future. So what additional skills they require or they should develop, to become a data scientist?
Yes. So to answer the first question from Naveen, for somebody to get started, they can actually become a data scientist without a certification, because the information is very readily available all over the internet, right? Where do you start? You start from basics. You learn what is probability, right? You learn how means and standard deviations and concept like this exist, and it will just take you from point 1 to point 2, point 2 to point 3. The world is so large that once you have built this foundation, you straight up jump to solving real world problems. Today, there are mechanisms, there are certain websites called Hacker Earth, there are a bunch of hackathons that run where real companies go, they share their data, they have a business problem, and you go there and you attempt to solve these, right? You are able to also look at other people's code or the technology that they had used also to, let's say, win that competition. So if you have your foundations, you can take a problem and you can start applying it, or at least use it and start editing it out. But that may not get you, you may start freelancing that way, but maybe because the competition is so huge, this evolving field, you may want to, maybe differentiate yourself through certification, right? Now, within India, there are a lot of courses that are run by most of the universities at this point, where if you're already working as a professional, you can choose one of the courses that is today offered by ISB, a data analytics course that is mostly distance at this point, where they start with very basics.
What
That
is
will
SB? Sorry, to interject.
ISB, Indian School
ISB.
of Business.
Okay. Well, Purva, I have a question regarding the guy who is working in other field, like professionals, like some 5 year or 10 year experience. Someone is in mechanical industry or somewhere else who doesn't have any experience working in IT industry or data analyst related company. And at this situation, if someone wants to shift to the data analysis, how should they approach actually? What should be the, it should be certification, and then where they should approach for the job. Because if someone has worked for example 10 years in a any automobile industry or anywhere else, it might not be so easy even after certification, because there are so many young engineer or fresh talent coming with the even much better knowledge. So how should they approach?
Got it. So one thing is that data science field is kind of different from other fields in the sense that they're not a very small number of players who are in a position to give the opportunities, right? If you are running your own company, or if there is a very small scale company, they can get started, and they can also be able to, in a situation where they are creating opportunity for someone to help them with from a data aspect. So uh, certifications and overall theoretical knowledge here will help formally, but doesn't stop anyone to not proceed. uh, right? If you are starting now, irrespective of whether you have, let's say, done, were a CS or IT graduate, or have been working in IT, if you want to start now, uh, the key aspect is that majority of the business problems today don't require the infrastructure, or let's say the big data infrastructure, or the the tools that are mostly used by large scale enterprises. All they need is somebody to tell them what does their data mean, synthesize what does this data contain. And therefore, in that sense, there are certain key concepts, your ability to make sense out of data in terms of certain terminologies like mean, standard deviation, basics of probability. All of these will help you get started, right? You will be given a data, you will be able to say the average demand is this, or the average transaction value is that, right? And then similarly, basics of, let's say, SQL will kind of help you start interacting with the data. A very simple problem can come up: who are the top three let's say students in a college by let's say numbers that they have accumulated over the semester. And all that needs is a query on the college's database, right? And then so that you can start interpreting the data. So this will help you get introduced to these concepts, dealing with the data. And the more and more complex the asks become, you yourself will be able to calibrate. For example, if I ask you a question: how do we improve the probability that more and more people from our college gets placed? Let's say that's a business question, right? uh, you have to have the mind to come up with different approaches. You will say, first I will analyze this data just by marks, then I will analyze this data by their the how many people are taking coaching, for example. Then I will analyze this data by some other dimension, and you will use SQL to query it out. And then you will have some hypothesis. You will say, historically, people who have more than 650 marks accumulated have got placed. So maybe you will say, now this year I will predict that these people will get placed on day one, right? and then you will realize maybe you were right, maybe you were wrong, and then you will ask again question, why did they not get placed? So maybe you will come up with some more insights and way to query your data differently. So nobody is stopping you to get these basics. Learning SQL or learning concepts of probability and stuff like that is very open. Wikipedia is where you can get started. How to make this more formal, right? Let's say there are a bunch of websites on the internet which are giving you real world data, large scale data, maybe a month or 2 months, that level of big data, uh, just to get their problem solved. So real companies will give their problems and they will run certain hackathons on that. Whosoever is solving this problem the best way will win the championship. So you can start attempting those, or you can see who were the previous winners, what sort of approach they had taken, both in terms of problem solving as well as code. That's very readily available. If you're engineer, or if you have done your engineering, or if you're right now doing your engineering, the idea would be to kind of have some of these foundational topics very clear, and then aiming for companies which are asking for freshers but specializing in this domain. There you will get a chance to learn a lot. But let's say you are already employed, you've already completed your engineering, then there are two ways to go about it. One is you can start picking up freelancing projects once you've built your foundation. The other one is try to get some formal education. You can choose to do masters, which specializes in data science domain. Of course, it will be easier for you to get into such a program, because now you have real world experience, and you just want to augment with data science as another complementary skill. So that will make your transition little bit easier. And then these are programs which usually last 6 months to a year, where you get concepts from a way to how to get jobs, right? The best but very, I would say, a challenging way is to be more and more visible in websites that I talked about. And a lot of hiring happens from there. I know companies which go to these websites and they see who won the last hackathon and they send them an interview request, and then they clear it, and now they have changed their profile. The other way is to solve a lot of freelance projects where you're solving real world problems, but for a lot of different clients, and then build a good resume and then start approaching people. The best thing is that like I was saying earlier, there is a theoretical aspect of it, but theory is only, it's the application which is mostly used by businesses, right? Nobody is talking in day-to-day terms, nobody is talking what is this algorithm doing, but that discussion is more about how you can use this algorithm to solve a business problem, right? That's something that you can very quickly learn. And you can also use it to showcase that, yeah, you, at least if you're not the depth of the algorithm, the breadth of the algorithms which exist. Given a business problem, you can understand whether it's a forecasting problem, it's a prediction problem, it's a prescriptive problem, what exactly it is. So Wikipedia and Google is to get started with, and then from one point to another, you will just keep on going.
So Apoorv, there are many advantages of data analysis or data science. And when we are talking about making career in this particular field, I just want to ask, and whoever is looking for making some job change, or maybe a student is looking forward to do something in this. So what are the different disadvantages of data analysis?
So there are disadvantages can be in terms of two aspects, right? One is somebody who is taking the services of somebody, a data scientist or data analyst. What are the disadvantages there? And for a data scientist also, the disadvantages for somebody who is thinking about taking this field mostly lies with their ability to grasp knowledge and apply it. Right? These are difficult concepts to gain understanding of, and they are evolving every day. So it is a very tough prospect for somebody to keep themselves updated, right? So then it becomes a challenge that they may start, right? They may start with the current set of mechanisms, algorithms, technologies that are available. Fast forward 5 years, what they know now is kind of becoming obsolete. and that they have become obsolete not because they started earlier or they are entering they entered earlier, but they did not keep themselves updated. Uh, Mostly what people do is they develop a depth in one aspect, that I have end-to-end knowledge of solving a problems like this, and they specialize in it. And then they have a breadth that at least they know, given a problem, what kind of problem it is, right? Whether what algorithms to apply, so that, and it's a community based, it's a very community based field. So if you don't know how to solve a problem, you will always have somebody who specializes in that field. It's very much how, let's say, doctors operate also. uh, so if you are not able to update yourself even in your field, that becomes a big disadvantage for the person themselves. uh, but from a career trajectory aspect, there are only advantages, because you are dealing with so many different domains. You may be solving an aviation problem today, a retail problem tomorrow, that you will gain business context very quickly, and that will result in you taking more leadership position in certain organizations maybe later, if you don't want to just keep yourself limited to data science. What are the disadvantages of this? Somebody who is taking the services is pure blind trust on what the data scientist is saying. That is the biggest disadvantage, because there is a little bit of ethical aspect there as well, that data can say what you want to hear, and it's very easy to make it that way, right? It starts from very simple. If you want to see whether team A or sorry, geography A is performing well or geography B, but if you have a hunch of that geography A is performing better than geography B, even the trends which are saying that geography B is performing better, you will just underlook them. You will not pay more attention to them. The data is so much used that the final 3 lines of recommendations that you are going to write, you are the owner of writing this, right? So unless you have subject matter expert or domain knowledge of that field, maybe you will end up giving a bad recommendation. Now the guy who is taking the recommendation, if they are not critical enough, if they are not asking the right questions, may take bad decisions. And there are a lot of anecdotes like this that exist all everywhere.
Right.
Okay.
I see. One question came into my mind when you were talking about disadvantages, and one of it is that, as you said, that if the recommendation is given by you, what if you give a bad recommendation? What will happen? I mean, how big the consequences can be, and how knowledgeable the person should be that he can read the recommendations and then ponder about it in great detail.
The answer to that is you can't cover all your bases, and therefore the approach that mostly people take is a very I would say pilot based approach, right? uh, there are real world applications where, let's say, when Facebook today tries to change their UI, which is coming after some data analysis, that let's say blue color helps people invest more time on Facebook UI, or having the login status of people is results in more people spending time on Facebook. More spending time means more ad revenue. If that was the so, and because of that recommendation, let's say Facebook has put more blue color in their page, right? They won't go ahead and launch this feature across the world. There are New Zealand is such a country where Facebook today chooses to launch most of their new features, because New Zealand is a good population, good country to a good subset of the Western population. How New Zealand will behave, that's how the rest of the West world will behave. Similarly, in India, if they will choose a metropolitan city to launch this behavior, and that's why you see there are beta programs that run where you only get to interact with product. So when recommendations come, mostly people judge them based on a very small set. They see that it's actually working right in the real world, and that's when they scale. Because you can't always ensure that the recommendations are always right.
I see. So the by pilot, you mean that first we will try at a small subset of, I mean, the whole data we use at small subset of population or wherever our machinery is, to try and see that if it works or not. And then we
Yeah.
extrapolate into a bigger, the whole world
Yes.
apparently. I
Yes.
see. So uh, now I go from macro level to micro level. What about small businesses? Imagine that now I'm not uh, richer than Elon Musk, and right now I have just opened a restaurant for myself, and I just, after not 6 months, maybe 1 year, I just want to see what improvements I can do. And can I hire a data analyst for that, a freelance data analyst, as you said? And can he help me at all?
In real world, to be very frank, if somebody's running their small business and it's only been 1 year, I don't think they're thinking about data at all. At this point, all this while they have been ensuring that customer demands are being met, and they are able to fulfill the orders, they are able to manage their taxes, so on and so forth. The journey of actually, the way you can think about data science or using data analysis, it's a luxury that comes after a business attains some maturity.
Mhm.
Because the basic crux of using data science is that you need to have the data pipeline set up. What if you have not been capturing the data all this while? If you've started today, the benefits can only come after a year, right? But let's say you have done that. You are a smart guy. You have started your small
I know.
business that way, right? And you have been capturing the right set of data. At this point, what a freelance analyst will essentially be able to do tell you is that mostly your problems will not be of the predictive kind. Mostly a problem will be of the prescriptive kind of what should I do, or descriptive kind, right? Where you have to tell what has happened in the past, just for you to make better sense out of it. Maybe you're dealing with taxes. How can I save taxes well? What was the impact of GST when it got launched to my business? So those are the questions that you will have, and that's where a freelance analyst will come and will say, after the GST launched, your profit on these kind of products improved, your profit on these kind of products reduced. Going forward, because this is there to stay, you need to change your diversifying of the products that you offer by this much, so on and so forth. Only when your scale is a bit bigger, let's say you have become a chain now, right? That is when your problems will be more of a predictive kind, in the sense that then your problems will be, if I were to achieve 1 million rupees or maybe 10 million rupees revenue by next year, how many new stores when because your business has already achieved that maturity, that those sort of problems start coming, and that's where you will want to more strategically look at data science as one of the key aspects of your business.
I understand. So actually, the responsibility is on the small or the business to plan ahead, collect the data, so that he can hire someone to use my data and give me fruitful recommendations, right?
Yes, yes, because a lot of I've seen very very big companies who hire data scientists, and they say, help us. And 6 months or 8 months down the line, you realize that the data quality is just not that good. Not every problem, machine learning or analytics can fit in also. We can give you good visualizations and pivots, but that's the end state of it. Maybe your business is not what can be realistically predicted. Maybe you're solving world hunger. Maybe you are an NGO, you're solving poverty, right? Now, these are the problems which are too subjective that converting them into objective or metrics or numbers will require a lot of research and lot of data, deploying data capturing mechanisms for you to even gain any benefits out. So some of, not necessarily every business problem even requires data science to gain good output.
The funny thing is that since the time you have said that the Facebook company has changed to blue, they changed it blue because they think that people are more online. What might be the input for that? Can you think of
See,
anything? I know you do not know, you do not work for Facebook, but what might be the input for? I mean, it is fascinating what data can people use nowadays. I mean, I have seen that sometimes I am thinking about buying a red t-shirt, right? And then all of a sudden, not only t-shirt, I'm getting recommendations online, obviously, for red shorts, for red boots. Even I don't wear them. So yeah, what what are these things? How they think about these things? And I'm fascinated. Just tell me something.
Right. So a typical ad recommendation, or in that sense, recommendations of movies on Netflix, or suggested friends on Facebook, right? A typical problem that all of these solutions are trying to solve is what keeps people more engaged, and that's the business problem.
No, but my question was that, as you said, that blue color of Facebook keeps people more engaged. Now my thinking is that, or I am just speculating. I do not know. I hope, and that probably you can shed some light on it, but you also don't know. But let's speculate together. What do you think that blue color keeps people more online? How did they get that data and then
Yeah,
extrapolate it to this data?
yeah. If you recall, in the beginning, I was saying about hypothesis, right?
Mhm.
A business problem, think of a meeting, a board meeting happening, and there are different subject matter experts. There is a guy who is a UI UX researcher, there is a guy who specializes in marketing, and there are similar such guys in that brainstorm meeting, right? And the business is, how do we improve ad revenue? Think of what sort of hypothesis the UI UX guy will put on the table. He will say color may impact people's time spent on Facebook. He will say larger words, font 12 or more will impact the people's time spent on the this thing. And he will come with a lot of such hypotheses, and none of that, you don't know whether they make sense or not, because you've not proven or disproven them,
Hmm.
right? So you will ask him, hey, color sounds good to me, what are you going to do about it? And he will say, okay, give me some time. What I'll do is I will identify on at random basis 1,000 people. What I'll do is, for 500 of them, I will increase the blue color, because that's our logo color. I will increase the blue. For the remaining, I will keep, maybe for 30%, 33%, I'll keep no change. And for the remaining 30%, I'll reduce the amount of blue, right? And what he will then do is, he will run this pilot for a month, and he will see if there is a uplift in terms of the time spent by these three groups on Facebook, right? And what he can then finally come up with a insight that, for the folks for which we added more blue in the app, they spend maybe 10 minutes on an average higher than the control one, where we did not do any change, and 20% more than the one where we reduced the blue. Now, this may come as a recommendation. The other aspect is that a question may come, but what about the other features? Maybe the third group, which actually invested more time, maybe all of those kids were college kids, and now there is a pandemic. But your other group was all old people or people who are actually essential workers. That may be one feature. That's where a data engineer comes, and that's where the whole engineering of the right kind of people, the right factors to consider to randomize the group, and all of those things come. Assuming the person has taken all of those prerequisites, they have done their due diligence, that the groups are identical except the color, then such a insight will result in such a change in the app by Facebook. Something, this is very ubiquitous. This is a very common problem in a lot of websites. Any company which has a website, they will be solving these kind of problems.
You know, the funny thing is that you said the word which was my last question to you also, that during pandemic many businesses grew like hell and many businesses got closed. And obviously the people who are working as an employee in corporates, they have their own problems. But what about this field? Because infrastructure building, industries, transportation, traveling, what else, hospitality, all these businesses suffered a lot. What if I had made a startup of my own who was expert in data science? What was the effect of pandemic on data science? Has it, because what happens, I have seen that, just for an example, take vaccine. When this pandemic started, we used to think that, oh, vaccine takes about 15 years to get approved by CDC or WHO. Now we got vaccine in 8 months. This pandemic actually, you know, what is called jump started many technologies. What happened to data science in this during this pandemic?
Yes. So to put it very in a small way, I would say that the number of opportunities have increased, but the number of opportunity givers have reduced. I'll tell you what I mean by that. Earlier, I was talking about what is your whether you can afford data science or not,
Yes.
right? Whether you can afford data science or not. Companies who were at the brink where they have just started on data science or they were thinking about using data science because of pandemic, because of the reduced customer demand. I'm talking about companies which are not dealing with masks, let's say. Because of reduced customer demand, they were on the crossroads of, do they invest now or do they wait? And they certainly have waited. They will just let this glide in and they will further accumulate the money, the luxury, and then they will invest on data science. So the number of opportunity givers that we have reduced. That in no way means that the number of opportunities have reduced. A lot of these people, real companies who don't have money at this point, they still want to understand what has happened. How has their business changed? How can they plan for future? And that's where you see, for a freelancer, the internet is filled with opportunities. They won't pay you that well, but at least they will give you a starting point, right? On the other side, the companies who were very much relying on data science or who not only can afford, they were making advancements in it, right? These are the companies who have used it very effectively. Just like you said that the time of vaccine have reduced from 15 years to 8 months, the time that some of these companies take to react to COVID or the COVID related reduced demand or what is essential item, that has also changed.
Yeah.
There are companies, for example, retail companies, and these are real world problems that when COVID started, you would see masks prices and sanitizer prices increased everywhere.
Mhm.
A company, essentially a lot of companies were struggling with this because of gamification, frauds, all of this going on, with a clear principle that every company wants to do the best for their customer. They were not increasing these prices to gain more profit, but because, let's say, they were getting impacted by other players. They came up with an approach, but one of the clear phenomena afterwards that was also observed was that at the same time prices of routers starting increasing, prices of HDMI cables started increasing, prices of floors, baby diapers, all of these things started increasing. The companies who were ahead of this game, they were able to predict that such a thing will happen, right? Because people are now staying at home, so there are gonna be so they were planning for it.
Mhm.
They were planning well for baby diapers, HDMI cables, so on and so forth. uh, Yet there were companies who may be behind this whole arc, who were just trying to mitigate the impact. uh, and there are winners and losers in COVID. Airline is one of the, and hospitality is one of the one which are still trying to adapt, while I see retail has adapted very well. The companies which deliver food at your place, they are able to come up with better algorithms that even one guy can deliver 10 houses. They are able to route the route properly, so they have also been able to do all of that.
I see. Hmm. I mean, it was quite interesting talking to you because, now my mind is a little bit more, what should I say, opened about data science because I am a mechanical engineer and we have a prejudice about computer science engineers since last 15 years. We don't think as it as a science. But now when you were talking about data science, I said, no, it is not a science. But what goes behind it actually, when you explain it to us, I am really fascinated by it, that how much thinking goes on in behind those computer screens. And one last question before we end this podcast. As a person, what should be the mentality or the thinking process which is best suitable for this kind of stream?
Right. uh, if you are interested in repetitive tasks or tasks which have a standard operating procedure, then this field is not for you. Because every week you might be solving a different problem. And the other key quality that you should definitely have is the ability to read complex things which you don't have any idea about, because your customer essentially will be expecting something that they not already know, and they might be working on this field for 20-30 years. And you have to not only bridge that gap of what they know through the data that they choose to give you, but also tell them what they need to do in future. And therefore you need to read a lot. You need to be very open-minded. There is no intellectual property in this field. There is no, if company X has done something, we will do thing Y, but we will not do what they have done. There is no intellectual property here. You use it, you reuse it, you make it better, and you make it open to everybody. Because at the end of it, this is just a means, this is just a mechanism for you to take better decisions. The decision is still taken by the business owners, right? So the guys who are the path bearers or the flag bearers of this field, they choose to keep things open. They choose to keep things accessible to everybody, because only when it is accessible to everybody, things become better. So that's one other thing. Just read more and have this curiosity. That's the key differentiator.
Fascinating, man.
That's great.
I mean, what can I say, that if there was no pandemic, I would have been there and would have shaken your hands right now, but I cannot. So take a high five, virtual high five from me. And thank you very much for giving us your time on your weekend. I know you work long hours and very you are using your brain quite a lot. I mean, it's another supercomputer which we abuse every day, but it is the part of our life. So anyways, yeah, thank you very much. And I hope then that in some years, when you have more knowledge, where there many things would change, we will call you back again. And even if you think in between that you can give some information, just contact me. I'm always available to know each and everything about anything. I mean, it is the whole purpose of me and my co-host here, that we want to learn about everything. And we are just bunch of excited people here who just get fascinated about smallest of things which is out of our realm. So with that, I will close this podcast right now, and thank you for watching this. Please like, share, and subscribe our channel. Ask your friend to subscribe. Yeah,
Sure.
you know, when you when you subscribe our channel and share it, probably we will get even more good topics, because people will start accepting our invitations and coming to our podcast, and that way we will make a new ecosystem here where we can get information about everything. So look into my eyes, please like, share, and subscribe our channel, and see you next week. Bye bye.
Bye.
Bye-bye.
Thank you.
Check the mic and make sure it sound right, boys. It sound right, boys. sound right, boy. It sound right, boy.